Hey guys, it's me again, and let's solve another LeetCode problem, merge two sorted lists. So this is an easy problem. It's a mainly fundamental problem. There's nothing crazy about it, but it's a pretty good problem to understand some basic stuff. So we're given two linked lists, right? So this is the first one, this is the second one. Both of them are already sorted, and we just want to merge them into an output linked list. The only catch is that we have to use the original nodes, right? Like we can't create copies of the nodes. So let's say we have list 1 and we have list 2. I'm just going to take them exactly from the example that they gave us so we can actually focus on the general algorithm itself. So your intuition will probably solve this problem for you. So it's basically, since the lists are sorted, we start at the beginning of both of them, right? Now we can just compare the values. So they're both 1, so it doesn't really matter which one we pick. So we can just take, I'll say list 1, right? So we'll take this one and insert it in our output and then move to the next one and then just continue the algorithm. The only catch here is that right now our output list is empty, right? So this kind of gives us an edge case because we don't even have a list itself yet. So what I like to do is just create like a dummy node. So this is a pretty common technique, and you avoid any edge cases. You avoid the edge case of the initial empty list. So let's say we start out with a list, right? This is a dummy node. It can have any possible value. So now we're going to insert 1 into our list. Now we're going to compare two values of 2 and 1. In this case, the value from list 2 is smaller, so we're going to take it, insert it into our output list, 1. Now we're going to be comparing these two, so 2 and 3. The value from list 1 is smaller, we take it and insert it into our output, 2. And then of course we can move to the last value in list 1. So now we're at 4 and 3. Which one of them is smaller? Of course 3, which is the value in list 2. I'm running out of space, but I think you get the idea at this point. So now we're at the two last values from each list. We'll just take the value from list 1 and add it, which is 4. They're both the same, so it doesn't matter. Now, this is the last edge case that we have to worry about. So now, for list 1, there aren't any more values left, right? So we can't really continue our algorithm. Lucky for us, there's only one value left in list 2, but it's not always going to be the case, right? Maybe there could be a bunch of other values, right? 4, 5, 6. There could be other values in list 2. Now, what would we do in this case? Well, we can do a really easy thing, which is just take the remaining portion of the list. So if we run out, so if one of the lists is empty, of course, the list 2 in this case is still sorted, so we can literally just take that list, insert it into the end of our result, right? So that's basically the idea. Okay, now let's write the code. So remember, I like, and most people like to use this technique of creating a dummy node, so you don't have to worry about the edge case of inserting into an empty list. The tail of our list is initially, I'm just going to say, the dummy. So now we're going to keep going. We're going to iterate through these two lists. What's the condition that we're going to do that? Basically, if both of them are non-empty, right? Because that's when we can actually compare the two values. So while list 1 and list 2 are non-null. So now we can do our comparison. So if the value of list 1 is less than the value of list 2, then of course we're going to take the list 1 value and insert it into our tail. So tail.next is going to be the node itself, right? List 1 node. And then we can, of course, update our list 1 pointer. Now, the else case is if list 2 is less than or equal, right? So if they're they were equal, the else condition would evaluate. So we're going to do the exact same thing, except list2 is going to be inserted. And don't forget, we do have to update our tail pointer, but the tail pointer is going to be updated regardless of which node we insert into our list, so that's why I'm not putting it in either of the conditionals. And you might be tempted to just say return dummy.next, return the list, but don't forget our condition was list1 and list2 are non-null. What if one of them is empty but the other one isn't right now? Well, in that case, we want to find the non-empty list and then insert it at the end of our result. So if L1 is non-null, then we'll say tail.next is equal to L1. So we're just taking that remaining portion of L1 and inserting it into the end of the list. Else if L2 is non-null, we would do the exact same thing with L2. Only one of them can be non-null. So let me just run it to prove to myself that it still works. And yep, it does. And some random percentages that always seem to change. Right now it's 65%, but I'm sure if I submit it again, it could be 10. The value from list 1 is small, next one gave us, so we can actually focus on the general algorithm itself. So your intuition will probably solve this problem for you. So it's basically, since the lists are sorted, we start at the beginning of both of them, right? Now we can just compare the values. So they're both 1, so it doesn't really matter which one we pick. So we can just take, I'll say list 1, right? So we'll take this one and insert it in our output and then move to the next one and then just continue the algorithm. The only catch here is that right now our output list is empty, right? So this right now it's 65.
So while if it's L1 should now be filled up next. What the fuck is still up? Oh,
Hey guys, I don't know why leak code is so inconsistent. Tail.next. Hey, same thing with L2. Only one of them can be. non-null. So let me just run it to prove to